This video covers section 2.8 on the distance and midpoint formulas and circles. So we're going to quickly go over the distance and midpoint formulas, but really those formulas are only in this section so we can apply them to circles later on. So the distance formula says that the distance between the point x1, y1 and the point x2, y2 is found by taking the square root of x2 minus x1 squared plus y2 minus y1 squared. So basically you're going to subtract the x's in square, you're going to subtract the y coordinates in square, you're going to add those results together, and then take the square root. The midpoint formula tells us that to find the midpoint of the line segment joining x1, y1, and x2, y2 is midpoint equals, this is an ordered pair, so we take x1 plus x2 divided by 2 to get the x coordinate, and y1 plus y2 divided by 2 to get the y coordinate. So basically an easy way to remember this is that you average the x values to get your x, and you average the y values to get the y. So we're going to do an example of finding both distance and midpoint between two given points. So if we're given -3, 5 as one ordered pair and 1, -4 as the other, to find the distance, we use the formula and say d, or distance, equals the square root of, so here we're taking the x value from one of our points, subtracting the x value from the other point, and then we're going to square that, plus y value from one of our points, subtract the y value from the other point, and then square that result. So when you simplify this, you want to make sure you simplify everything under the square root sign and then apply your square root at the very end. So 1 minus -3 means 1 plus 3, which is 4. Then we're going to square. Plus -4 minus 5 is -9. And we still have to square. So when we square 4, we get 16. When we square -9, you get 81. Then we're adding those results together, so we end up with 97 under the square root. So our answer is distance equals the square root of 97. If this is a number that would simplify under the square root, you would need to do that. To find the midpoint between the same two ordered pairs, we use the midpoint formula. So we're going to take the x value from our first point and add the x value from the second point and divide by 2 to get our x coordinate. And then take the y value from the first point, add the y value from the second point, and divide by 2 to get the y value. So -3 plus 1 is -2 over 2. 5 plus -4 is 1 over 2. And then simplifying -2 over 2 gives me -1 as the x. And then 1/2 just stays as 1/2 as your y. So the midpoint would be at the ordered pair -1, 1/2. All right, next we're going to talk about circles for basically the rest of this section. We'll eventually use our midpoint and distance formula with circles at the very end. So the standard form for the equation of a circle is this: x minus h quantity squared plus y minus k quantity squared equals r squared, where the ordered pair hk is the center of the circle and r is the radius of the circle. So the center means the point in the middle, and the definition of radius means the distance from the center to any point on the edge. So if we locate the center and we know the value of the radius, we can find several points along our outer edge to draw the graph. So we're going to start by writing equations, then we'll look at how to graph a circle. So anytime it says write the standard form for the equation of a circle, your answer should look like this. So you need to know the center coordinates and you need to know the radius and plug them in. So let's look at a couple of examples. Write the equation for the circle with given center and radius. So part A says the center is the ordered pair 2, 0. So that means 2 is the h and 0 would be the k. And the radius value is 4. So we're just going to substitute in up to our standard form. So x minus h, right? H came from here being 2, squared, plus y minus k, k was the 0, squared, equals r, which was 4, squared. I'm just plugging into here. So we're going to leave this as x minus 2 squared. Here we can drop the 0 because you don't need to say subtract 0 because it doesn't change anything. So y minus 0 is just y. So that would just be y squared. And then 4 squared is 16. But that's all you would do. You don't need to FOIL this out or do anything else. Let's do one more. This time the center is given as the ordered pair negative 3, 5. So that means negative 3 would be h and 5 would be k. And r is equal to the square root of 6. So the same idea. So our standard form says x minus h, h being negative 3, squared, plus y minus k, k being the 5, squared, equals r, which is the square root of 6, squared. Here to simplify, you would want to clean up your two negative signs and rewrite this as x plus 3 squared, plus, this one can stay like it is, y minus 5 squared. And the square root of 6 squared, when I square a square root, it removes the radical. So this just ends up being 6. Right? This time they're going to give us the standard form or give us the equation of a circle, and we have to find the center and radius and use it to sketch the graph. So find the center and radius and sketch the graph. So if we're given an equation of a circle that looks like this, meaning it's in standard form, right, we can just look at it and write down our center and radius. So this, remember, is x minus h, so that means h is 1, squared, plus this would be y minus k. So if the standard form says there should be a minus a k, that would make k having to be negative 2, because minus negative 2 would have been plus 2. So it's basically the opposite of the number that's inside of here. So if there's a minus 1, it's a positive 1 value, and if it's a plus 2, it's going to be a negative 2 value. So h would be 1, k would have to be negative 2. This side is r squared, so to get r, we square root that number. So r would be 3. So once we have the center and radius, we're going to plot the center first. So plot the ordered pair 1, negative 2 right here. And then to sketch the graph, we're going to use our radius to find points along the outer edge. So if the radius is 3, I could go 3 units in any direction. So if I move 3 units to the right, I could plot a point. If I go from the center 3 units up, I could plot a point. If I go 3 units left of the center, I could plot a point. And then 3 units down, I could plot a point. And then those points can connect together to form the graph. So we're not going to make a table for circles, we're just going to use the center and the radius. Part B, we're asked to do the same thing, but notice this is not in standard form. So earlier in section 1.5, we talked about solving quadratic equations, and I mentioned that you would have to know how to complete the square to do other things later, and this is one of those things. In order to put this in standard form, we have to utilize the idea of completing the square. Okay, so our first step, if we're given something like this, is to find the x squared term and any other term that contains x and just rearrange things. So x squared plus 12x, we would just write down first. So all I did first was write down x squared plus 12x, and I put plus blank. I didn't have this 36 here yet. Plus, then do the same with the y's. Y squared minus 6y, so the y squared was here, minus 6y, plus blank. I didn't know this yet. We're going to talk about how to get that number in a minute. equals, and then you're going to move this constant term to the other side. So adding the 4 over here. And then because I'm going to have 2 blanks here to add numbers, I'm going to have to put plus and then 2 blanks over here. So I'm going to have to do the same thing on both sides. All right, so then to fill in your blanks, this is where we complete the square. Notice that in this section, all the coefficients of x squared and y squared will already be a 1, so you don't have to worry about that. So we're going to look at take half the coefficient of x, so half of 12, and square it. That's going to be what we have to add in our blanks. So to add in the blank with the x variables, half of 12 is 6, squared is 36. So that's how I knew to add a 36 here. So if I added a 36 here, I have to balance it by adding a 36 on the other side. Then with the y variable, we do the same. We take half of this coefficient of y, so half of -6 is -3, then square it, gives me a 9. So that's how I knew to add a 9 here. And then if I added a 9 on the left, I have to balance it by adding a 9 on the right. So once you've added those numbers, this trinomial should factor into a perfect square. X squared plus 12x plus 36, the factored form is x plus 6 squared. Basically, it's x plus 6 times x plus 6. The y trinomial, y squared minus 6y plus 9, also factors as a perfect square, would factor into y minus 3 squared, because it would be y minus 3 times y minus 3 in factored form. So this is the trick, right, to put the right numbers here to make these factor as something squared. And then these numbers just get added together and I get 49. So from here, I can tell that my center is at -6, 3, x minus h would be -6, y minus k would be 3. This is r squared, so that would make r 7, the square root of 49. And then like before, we can plot our center, go left 6 and up 3, plot that point, and then move 7 to the right, go 7 up, 7 left, and 7 down, and then be able to sketch the graph. Our last example is going back to utilize the distance and midpoint formula along with our standard form for our circle. So we were asked to find the equation of a circle if 3, 9 and 7, 11 are endpoints of the diameter. So when they give you endpoints of the diameter means the distance across a circle through the center. So it's all the way across where it hits the center. So the center point is the C and the diameter is the distance all the way across. So we're given these two endpoints. So to find the center of our circle, we find the midpoint of the diameter. So we use our diameter endpoints in our midpoint formula. So 3 plus 7 over 2 for the x, 9 plus 11 over 2 for the y, so 10 over 2, and 20 over 2, which is 5, 10. So that would be our h and our k. Now we need the radius. So the radius is the distance from the center, which we already just found, to either of these endpoints, right? The distance from the center to the edge. So I can go from the center to the 3, 9 or from the center to the 7, 11. It doesn't matter. So my center was 5, 10. And one of my endpoints, I'm just going to use the 3, 9. Just pick one. So radius equals, this is my distance formula, the square root of x value minus the other x, so 3 minus 5 squared, plus y value minus the other y, so 9 minus 10 squared. And then cleaning that up, 3 minus 5 is -2. We're going to square that in a minute. Plus 9 minus 10 is -1. That also is going to get squared. So when I square the -2, I get a 4. Plus, and when I square the -1, I get 1. So I get the square root of 5. So the square root of 5 would be r. And once I have h, k, and r, I can plug into my equation. X minus 5 squared plus y minus 10 squared from the h and the k equals r square root of 5 squared. So x minus 5 squared plus y minus 10 squared equals 5. Because remember, the square cancels the square root. And that's the end. So that is the end of section 2.8.